All right, so we're diving deep today. You ready?
Always.
Awesome. Into the TCP/IP and OSI models.
Okay.
The basics of data communication and computer networks already. So we're going to skip that part and zoom right in on these frameworks.
Right.
Think of them like blueprints for how data gets around the internet. It's like once you understand these models, it's like having X-ray vision right into the internet's inner workings.
Yeah.
So let's start with an analogy that everyone can wrap their heads around.
Okay.
Imagine sending a letter.
Yeah.
You write it, put it in an envelope, address it, add postage, then you drop it in the mailbox. Each of those steps has a specific purpose.
Yeah.
Right.
Of course.
And they all work together to get that letter delivered.
Right.
Well, the TCP/IP and OSI models work in a similar way,
Yeah.
with each layer having its own specific role to play in the data's journey.
Makes sense.
And luckily, we've got our expert here who can unpack all of this and explain why we even care.
Well, what's super fascinating about these models is how they use this idea of layering to create clean interfaces between different parts of the network. So
Okay.
it's like building with Legos.
Okay.
You can swap out different blocks as long as they connect the right way.
Interesting.
And that idea is really important in network design.
Okay.
One of our sources, Computer Network's 5th edition, actually puts it this way. When network designers decide how many layers to include in a network and what each one should do, one of the most important considerations is defining clean interfaces between the layers to make it simpler to replace one layer with a completely different protocol or implementation.
Wow.
Having those clean interfaces means we can upgrade parts of the network without having to totally redesign the whole thing.
So it's like I can upgrade from dial-up to fiber optic without changing how I address my emails.
That's a great way to put it, yeah.
That's pretty slick.
Exactly. And that's one of the reasons we've seen such quick advancements in internet speed and functionality.
Yeah, that's
Yeah.
a really good point. Okay, so layering equals flexibility equals innovation. Got it. Now let's talk about the two stars of the show, TCP/IP and OSI.
Okay.
They both use layering, but they're not identical twins, are they?
Yeah, you're right. The OSI model is kind of like the idealized blueprint.
Okay.
It has 7 layers: physical, data link, network, transport, session, presentation, and application.
Wow.
It's very thorough.
Okay.
TCP/IP, on the other hand, is more streamlined.
Okay.
And it just has 4 layers: network access, internet, host-to-host, and application.
Okay.
And actually, TCP/IP came before the OSI model.
Oh, really?
Yeah, and it became the main model for the internet as we know it.
Hold on. Rewind a bit. You said TCP/IP has 4 layers, but OSI has 7. What happened to the other 3? Did they just get lost in the internet ether?
Not exactly. The application layer in TCP/IP actually takes on the responsibilities of those top 3 layers in the OSI model. So session, presentation, and application.
So TCP/IP is like, let's cut to the chase and get this data moving.
You could say that, yeah, it prioritizes efficiency for sure. And that leaner structure was part of the reason it became so successful.
That makes sense. All right, so we've got these layers, but I'm still trying to picture how this works in the real world. Can you give us some real-world examples?
Absolutely. So let's start with something you can hold in your hand, a coaxial cable.
Ah, the cable that causes so many problems when you're trying to hook up your TV.
Exactly. And that coaxial cable operates at the very bottom layer of both models, the physical layer. This layer is all about the transmission of data as electrical signals. It's like the physical road that the data travels on.
So that's the foundation, like the envelope in our letter analogy.
Exactly. Now let's move up to the data link layer. This is where things get a little bit more interesting. So imagine you're sending a message, but some of the bits get flipped during transmission. And that could corrupt the whole message.
Yikes, that sounds bad.
Yeah, it is. But luckily, we have error correction mechanisms to prevent that. And our source mentions Hamming codes as an example. And these codes are like spell check for data. They can detect and correct errors that happen during transmission.
So Hamming codes, they swoop in and save the day, make sure our data arrives in one piece. That's good. But once the data is error-free, how does it know where to go? The internet's a big place.
That's a great question. That's where the network layer comes in. This layer is all about routing. So figuring out the most efficient path for data to travel across networks.
Like a GPS for data packets.
Exactly. And the algorithm that helps with that routing is pretty cool. It's called Dijkstra's algorithm, and it's all about finding the shortest path between 2 points in a network. And our source goes into detail about how this algorithm works, and it's really quite clever.
So it's like a super smart map that helps data find its way through the internet maze.
Yeah.
Amazing. I'm already starting to see how these models that seem so abstract actually underpin everything we do online.
Yeah.
This is blowing my mind. but I know there's more to come. I'm ready to keep diving deeper.
Me too. Okay, so let's move up to the transport layer.
Okay.
This is where we really start to see some of the magic of these models.
Okay, transport layer. I'm intrigued. Tell me more.
Yeah, so the transport layer is responsible for things like segmentation and flow control and error recovery.
Okay.
So imagine you have a really big file. You want to send like a movie or something.
Yeah.
It's way too big to send as just one chunk of data.
Right. It would be like trying to stuff an entire movie into one envelope.
Exactly.
Not going to happen.
So at the transport layer, that data gets broken down into smaller, more manageable segments called packets.
Okay.
And each packet has a header that has info about its destination and sequence number.
So it's kind of like dividing a movie into scenes and labeling each scene?
Yeah, perfect analogy.
Okay.
And then at the receiving end, the transport layer puts those packets back together in the right order to rebuild the original file.
So even if the packets arrive out of order, the transport layer knows how to put them back together?
Exactly.
Wow, that's pretty impressive.
It is. But it's not just about putting things in order.
Right.
The transport layer also manages the flow of data to prevent congestion.
Oh, yeah, like that digital doorway pileup.
Exactly. So the transport layer uses things like flow control to make sure that the sender doesn't overload the receiver with too much data at once.
So it's like a traffic cop for data, making sure everything flows smoothly without creating gridlock.
Exactly. And if any packets get lost or corrupted along the way, the transport layer also takes care of retransmitting them.
Wow, this layer is a multitasking superhero.
Right.
It segments, it orders, it manages traffic, it even recovers lost data.
It's pretty amazing.
It is. And now, within the transport layer, we have two main protocols,
Right.
TCP and UDP.
Right.
And these offer different ways to deliver the data.
Exactly.
So it's like choosing between a registered letter and a regular one.
Exactly. TCP is like that registered letter. It establishes a connection between the sender and receiver before any data gets sent.
Okay.
So it's like a virtual handshake, just to make sure both sides are ready to communicate.
So it's all about that guarantee of delivery.
Exactly. TCP makes sure that data arrives in order and without any errors, just like that registered letter with the signature confirmation.
But what about the regular letter analogy? When would we choose that over the registered one?
Right. Well, that's where UDP comes in.
Okay.
UDP is a connectionless protocol. So it doesn't establish a connection before sending data.
Okay.
It's more like throwing a letter in the mailbox and hoping for the best.
So faster but less reliable.
Exactly.
Right.
So UDP is faster and more efficient because it doesn't have the overhead of establishing and managing that connection.
Right.
It's great for things where speed is really important and, like, occasionally losing data isn't the end of the world.
So like streaming video.
Exactly. A few dropped frames here and there.
Yeah.
Big deal.
Right, but like a missing digit in your bank account, that's a big deal.
That's a huge deal.
We don't want that.
Exactly. So TCP is like the reliable workhorse for that critical data, and UDP is...
Got it.
Oh.
Okay, this is all starting to click. We've gone from like physical cables to error correction to routing, and now to these really sophisticated data delivery mechanisms.
Right.
It's amazing how much is happening behind the scenes to make the internet work.
Yeah, and all of that is possible because of the layered architecture of these models.
Right.
Each layer has its own job to do.
Right.
And they all work together to make communication happen all over the world.
It's pretty amazing.
It is.
This deep dive has given me a whole new appreciation for the complexity and the brilliance behind these network models.
Yeah.
But I'm curious, what about the application layer?
Right.
That's where we as users interact with the internet, right?
That's right. The application layer is the top layer.
Yeah.
And it's the one we're all most familiar with. It's where all those apps we use every day live, like email, web browsing, video streaming, online gaming, even this podcast.
Whoa, hold on. This podcast is happening at the application layer of the TCP/IP model.
It is.
That means our voices are being converted into data packets and segmented and routed across networks and reassembled and then converted back into sound waves so our listeners can hear us.
Yeah.
That's wild.
It is pretty cool. And all of that happens like instantly thanks to these network models.
Yeah.
So the application layer, it provides that interface between all those underlying network processes and the user applications that we interact with.
So it's like the application layer is the translator between this complex world of networks and like the user-friendly world of apps and websites.
Yeah, exactly. It provides all the tools and the protocols that applications need to talk to each other, to the network. So it's like the common language that different applications can speak, even if they were made by different companies or run on different operating systems.
So that's how my email app on my phone can send a message to your inbox on your computer. even though they're totally different devices.
Exactly. The application layer takes care of all those behind-the-scenes details, like formatting the message, addressing it correctly, and making sure it gets delivered to the right place. And it does all of this for a ton of applications all at the same time.
It's kind of blowing my mind. We've gone from physical cables to error correction to routing to data delivery, and now we're talking about the very layer where we experience the internet.
Right.
It's like we've zoomed all the way in from the infrastructure to the user interface.
It really is a fascinating journey, and it just highlights how powerful and complex these layered models are. They've allowed the internet to grow from this small network of research computers to the global communication platform it is today.
Yeah, it really is amazing to think that all this complexity is happening behind the scenes. We're just browsing the web or streaming videos or sending messages, totally unaware of this intricate dance of data packets and protocols.
Oh, yeah, and it's really a testament to those engineers who designed these models.
Yeah.
They created this system that's both robust and adaptable. It can handle all these new technologies and applications and still maintain its core principles.
So what do you think the future holds for these models? I mean, will they still be the foundation of the internet as it keeps evolving?
That's a great question.
Yeah.
It's impossible to predict the future.
Right.
But I think it's safe to say that the principles of layering and abstraction and those clean interfaces will remain really crucial for the internet to keep growing.
That makes sense. I mean, these models have stood the test of time.
Right.
And they've shown just how adaptable they are.
Exactly. And as new technologies come up, things like 5G, the Internet of Things, artificial intelligence, all that,
Right.
These models are going to keep providing that framework for connecting devices and making communication happen.
So even as the internet changes and grows, these models will still be like the underlying blueprint.
Very likely, yeah.
Okay.
Of course, there might be some tweaks and improvements down the road.
Right.
But the fundamentals of these models, they're timeless.
This deep dive has been such an incredible journey. We've gone from the physical layer all the way up to the application layer, and it's given me a whole new understanding of how the internet works. I feel like I've got a superpower. Now I can see this invisible world of networks.
It is a power worth having for sure. And the more we learn about these models, the more we can really appreciate this web of technology that connects all of us.
Well said. I think it's time to wrap up this deep dive.
Yeah.
Thank you so much to our expert for guiding us through this fascinating world of TCP, IP, and OSI models.
Happy to do it.
And to our listeners, we hope you've enjoyed this journey as much as we have.
Yeah.
Remember, the internet may seem like magic, but it's all built on these models. So next time you're browsing or sending a message, take a second to think about that complex symphony of data that's happening behind the scenes.
Yeah.
Keep exploring, keep learning, and keep diving deep.